Welcome back to another episode of our 300B build. And honestly, I never expected this series to go in the direction it has. I did a lot of research before I decided on this schematic for this 300B amp. There's easily 24 websites with people talking about building this exact schematic and how fantastic it sounds, and people spending thousands on silver wire and Lindell output transformers or ISO Tango stuff, and just praising how fantastic this thing sounded when they were done. The BoyuuRange A50 that's being sold on Amazon right now is using this schematic, and I never expected it to be this bad. I mean, I thought maybe this isn't the perfect holy grail, but that it's got to be decent. And it's just not. I was really starting to question, and some other people had questioned in some forums about, oh, you've done something wrong. You messed up a resistor value, or you've got some wires in the wrong place or something. And I measured every resistor before I put it in the system. I always do that because sometimes these resistors, it might say 680K and it's 720. So you have to make sure that it is what it's supposed to be. And I know all the resistors in this thing are right. I've gone over the wiring 3 times. I know this thing's wired right. And then what really convinced me that I'm not the only one that's dealing with this, a forum post, this guy was talking about they had an amp shootout, and this guy bought one of those brand new BoyuuRange A50 300B amps, and he said the group was literally laughing at how bad it sounded, and it had no bass. And then they hooked it up on the oscilloscope, and they got the exact same readings that I'm seeing. That this thing puts out less than 2 watts, got asymmetrical clipping, and from listening to it, it's got no bass. And so, again, I'm almost embarrassed that I got fooled into thinking that this was a great schematic to be basing an amplifier off of. And I mean, there's a part of me that wants to just take this whole video series down, but I think there's value in showing that just because you think something is going to be good, especially in the audiophile world where they're selling things like noise harvesters that you plug in your wall outlet that converts EMI noise into light, and people are buying those. There's so much misinformation about audiophile stuff that I think this really does have value. So last night, I started working again on this amp, changing the operating points in the 6S and 7 part of the circuit, because I believe that's where the problem is. I don't think there's anything wrong with the way the 300B is implemented. It's what's driving it. And I looked at some of my other successful amps and realized that I needed to drop the resistor value between the B plus that's going to the 300B and the driver stage in that RC network. So we reduced it to, I think I was going to go 4.7K, but I found some 5.1K, so I put those in it. That's close enough. And then I ended up replacing the 27K with a 47K. And what we're trying to do is get more voltage drop across the plate load resistor so that we can get some more drive out of this cascode. And I ran into a little problem with the voltage getting a lot higher on the power supply side of the plate load resistor, and with the voltage divider going to the grid, and I'll explain that more later. But once I got that voltage divider dialed in to get the grid voltage on the upper section of the cascode back to around 92 volts, I got another 30% of drive at least 20% drive out of this 6SN7 cascode. And we're now getting what I believe is going to be enough drive to make this 300B tube really sing. And so I'm going to show you the results on the scope, and then there's some other things. I may end up spending all day working on this amplifier trying to get this thing finished up. I want to probably going to put some grid leak resistors in it, and I want to play with the cathode bypass the cathode bypass capacitor on the 300B. I may try doing some bypassing some of the electrolytic caps with some film caps, and see if I can get to the root of this smearing that I'm hearing out of this amp that I'm not real happy with. But I think we're getting close. And again, initially I was just going to build this thing exactly like the schematic that all these people and places online were saying was a really good sounding, the quintessential triode amp. And I'm learning that it's really terrible. And we're almost starting over from scratch. Also, if I really thought these 6SN7 tubes were not capable of driving a 300B, I would have given up on them. And initially I was kind of leaning there, but now I believe we've gotten to a place where they're really going to sound good. So let's get on the scope. Okay, we got the amp on the scope, and the main change that we've done here is we changed the two 27K resistors. One of them was in the RC network feeding the driver, and the other was the plate load resistor. We changed those out to a 5K in the RC and the power supply, and put a 47K as the plate load resistor. And then we've adjusted the voltage divider to compensate so that the grid of the upper section is at the same 92-ish volts that the other tube has. And so I want to show you the difference that this has in the drive of this amplifier off a 3-volt peak-to-peak input signal. So this is the unmodified signal. And as you can see out of this 3 volts in, we're getting, this is on a 5 volts per division, we're getting 5, 10, 15 volts out. So I'm going to switch to the other channel. Okay, here we are on the other channel. And right there at like 95% volume on the knob, we're getting a little clipping. So if we go right there, you can see we're getting 5, 10, 15, 20 volts of drive out of this amp with 3 volts in, which comes out to right at 6 watts RMS, which for the operating point of this 300B into a 5K transformer, I feel like we're in a good spot. I'm going to show you one other thing real quick. I'm going to switch back to the other channel. Okay, here we are on the other channel. We get back up to our 15 volts that were out at full volume. Now if we turn up the input signal, we get the same clipping at 20 volts. So we're not clipping early with the other setup. I think we're just up against what we can get out of these tubes without running into distortion on the driver's side. So I want to show you what the voltages look like on the grid of the 300B and how much drive we're getting out of this cascode. So for this test, we've switched to the 10x setting on the probe, and we're checking it after the coupling capacitor to make sure we're not putting all the DC voltage into the oscilloscope. I don't think it's over what this scope can handle. It can take up to 400 volts, but there's no point in checking it there. And we also want to see if this coupling capacitor has any effect on what we're seeing on the output. So here we go. And this is set to 20 volts per division. And so this is on the previous version of the cascode. We're getting 20, 40, 60, 80, 100 volts peak to peak at the grid of the 300B tube. Now we're going to switch the probe over to the other channel and see what it's doing. And as you can see, the waveforms mimic each other. I'm not seeing anything weird where where the top's fat or skinny or any distortion of the wave. It looks identical. But as we turn it up till we start seeing some clipping, which is right there, we're getting 20, 40, 60, 80, 100, 120, almost 100 and a little over 130 volts peak to peak out of this new cascode design. So we've picked up over 30 volts of drive into the grid of the 300B tube, changing 4 resistors. And that's what tuning amplifiers is about, is figuring out these small changes or these inexpensive changes in parts that can make a huge difference in the performance of the amplifier. So what I want to do now is I'm going to change out the other channel, and I want to show you the problem that it had when I didn't adjust the voltage divider, and show you what a distorted sine wave looks like when things aren't happy. So let me get that done and we'll be back for that part of the video. Okay, so I changed the RC network filter to increase the B plus going to the driver stage on the left channel now, and change the plate load resistor, but I didn't adjust the voltage divider to the grid to show you what that looked like. And when I first did this, I was thinking, I'm not sure I'm going in the right direction. But then after I corrected the voltage divider, I realized I was. So when I turn the volume up, you can see it starts clipping just a little over the 15 volts out that it was before. But look how distorted the waveform is. See how fat it is here and how sharp this one is? And if we put them on top of each other, you can see they're not even the same shape anymore. That's going to sound bad. That will never sound good. If you start seeing a waveform like that when you're working on an amp or making changes and you're checking the scope patterns, and that's why a scope is so valuable to have when you're working on something like this, so that you can visually see when stuff is like that's, you can just go, I know that's not going to work. Because here's the other channel when we got the voltage divider set right, and you can see these scope patterns, they sit right on top of each other. And so we know that's going to sound good. That's what you want to look for. So I wanted to show you that so that you would understand what I was talking about when I say that the scope pattern was all wonky. That's what I'm talking about. And you can see in this other channel, now we're getting to this 20 volts peak to peak once we get the voltage divider thing sorted out. So I'm going to go fix the other channel, finish getting the voltage divider fixed on it, and I'm going to go hook this thing up and go listen to it for a while and see what this thing sounds like, and then take it from there. We probably are going to come back on the bench and put some grid stoppers in, and which was not part of the original schematic, but I think that's going to be a good idea as well. And I'm also going to change the cathode bypass capacitor on the 300B to a higher quality audio note one, and then go listen to those changes and see what that sounds like. So let me go do that stuff, and we'll be back in a little bit. Well, I just got back from listening to the amp after I made the changes to the drive on the front end, and all I can say is, wow, that fixed everything. This amp sounds fantastic now. So when people were telling me that a 300B needs a lot of drive to sound good, they're not kidding. That's what really makes one of these sing or not. And I wouldn't have believed it if somebody said, well, you know, the same drive that you'll get at half volume, you could get at 5/8 volume, is going to sound the same. It doesn't. So anyway, the amp now has the drive that I would expect out of an amp like this. At half volume, it's plenty. Where before, to get the same sound pressure level, I would probably have to turn it 5/8, almost 3/4 volume to get that same power out of it. So that made a huge difference in that. It fixed the detail. It cleaned up everything. This amp sounds fantastic now. I did come back and I put a 100 ohm grid stopper on the 300B because it's just good practice to use a grid stopper. I don't feel like the 6SN7 needs one. It's such a low MU tube. I really don't think it's going to be a problem with it oscillating, but the 300B is a good idea to put some sort of a grid stopper on it. And then I listened to that, didn't make any difference at all, so that's good. Totally transparent, just kind of a safety thing to keep the tube from protected. And then I did go back in and replace the 100 UF 160 volt Nikon cap with this audio note 100 UF 100 volt electrolytic, and I think it helped a little bit. Pretty subtle. One of those things that you may or may not even notice it. I wouldn't jump up and down about getting excited about, getting a fancy cap for that position. Probably is not going to hurt anything. It does seem to, especially in the bass, one of my test songs is Madman Across the Water, and there's kind of a crunchy bass section in there that's a really good test for if the capacitors are reacting fast enough, and with that audio note in there, sounds great. Sounds just like it's supposed to. So it's up to you whether you want to spend that extra money or not. This is a budget build, and so that might be something you want to skip on. I don't think they were real expensive, but it's the same thing on the coupling caps. You may decide that you want to save $50 and put some cheaper capacitors in it, and at the end of the day, what really woke this thing up was getting the front end pushed to where it's driving enough swing to make the 300B sing. So I'm going to switch back. We're going to go to the schematic, and I'm going to show you the changes from the last version to this final version, and then we'll do a quick wrap up. Okay, I'm going to quickly go over the changes to the schematic. We've gone over this in detail a few times, so I'm not going to repeat all of that, but the main changes that I've made since version 2, which was when we changed it from the direct coupled triodes to the cascode, we're biasing the lower section of the cascode with a combination of an LED and a 50 ohm resistor. This is a 1.6 volt little tiny red LED that I've tried these before. They really sound good. They sound better than just like a regular cheap little LED. We come up with 1.8 volts on the cathode of the first triode. By using this LED, which acts like a bypassed resistor, but it doesn't have the capacitor, so you don't have to worry about the capacitor coloring the sound of the amplifier. And then using a small resistor, this gives just a very slight bit of negative feedback into the driver stage, which helps reduce distortion and just cleans up the sound. And I've found from experience that this sounds really good compared to this setup. So the other change we did is we changed the voltage potential on the plate of the top triode in the cascode. So we reduced this 27K to a 4.7K, which raised the voltage from 310 to 400 volts before the plate load resistor. Then we went from a 27K to a 47K plate load resistor. So now the voltage drop across this resistor, we go from 400 to 165 when we were going from 310 to 190. So we have a lot more voltage swing potential here across this plate load resistor. Well, when we changed this resistor and raised this voltage up, that affects this voltage divider that we created that powers the grid of the upper section. And so we had to change from this 470K 220K combo to a 680K 200K combo to get very similar voltages. And the actual voltage here isn't super critical. Like here it was 98 volts and 100, and here it was 92 volts and 94. As long as you get it in this 90 to 100 volt range with 2 volts difference between the cathode and the grid, that creates the 2 volt negative bias that we want to see on this grid, it'll be fine. The last couple of small things we did, I added a 100 ohm grid stopper on the grid of the 300B, and you want to solder this to this resistor as close to the pin as you can. I mean, jam the resistor right up against the solder lug on the socket so you can get this resistor as close as possible. The last change was on this cathode bypass capacitor. This was a 100 UF 160 volt Nikon, and we changed it out for a 100 UF 100 volt audio note electrolytic. And so that's the changes we made, mainly changing this voltage potential across this plate load resistor and then correcting this voltage divider. That's what fixed this amp and gave it all the drive that it's got now and makes it sound so clean. So, gonna flip back over for some final comments. So I think that's going to wrap up this 300B series. I'm glad to get this one under my belt, and hopefully within the next few days I can put together the complete BOM. I will get the schematics uploaded, and I do need to find some time to work on my website so I can have a repository for all this stuff. For now, I'm just putting it on Google Drive, and I'll come back and edit the description and put the link to the BOM and the schematic there. I can't say enough good things about the way this amp sounds. The way it was built with this J.C. Morrison, Sun Audio, whoever wants to be attributed to it, you know, there's that A50 amp that they're selling on Amazon, the BoyuuRange, or some of these current production made in China 300B amps they're using this schematic, they can't possibly sound good. I mean, if you've never heard a tube amp before, you might think it's okay, or if you had some super efficient speakers where you were only using like 1 watt, you might think, oh, this sounds good. But if you're going to do that, if you only need 1 watt, why are you spending $1,000 on a 300B amp? And I feel like that this amp coming in at $900 when the made in China ones are $1,000, this is so much higher quality components, and the sound quality, there's no comparison. So if you like my channel, please subscribe, like the video. Again, this is the end of this series, and our next build's probably going to be the phono stage. because I'm still waiting on the transformers for the 6SQ7 EL34, and I don't really want to get started on that until I have all the parts here where we can wrap it up, because I know y'all aren't going to want to wait a month or 6 weeks for the next video to come up in the series because we don't have all the parts here. So anyway, hope you're enjoying this. I know I am, and you have a great day.